Hello everyone, welcome back to this video series on clinical SAS SDTM programming. In this video, we will see how to create an example exposure domain, which is EX. So let us try to understand the concept of EX domain first, and then we will move on to the lesson description, specification, and programming. So in clinical trials, we administer study treatments to the subjects over time as per requirement. So we need to report the exposure of these study drug administrations in terms of protocol specified unit. So SDTM standard has a standard data structure for reporting such data, and we call it as exposure, and it is abbreviated as EX. So let us try to understand the word protocol specified unit. So what does it mean? So we'll try to understand the meaning of it in terms of examples. We'll see three examples. So the first one says the protocol may specify that 50 mg of drug will be administered, but the collection is in terms of tablets administered. Let's say to receive 50 mg, the subject has to take two tablets of 25 mg each. So we report the number of tablets taken in EC domain, which is exposure as collected. And we translate the information from number of tablets and the strength of the tablet. In this case, so we said 25 mg is the strength of each tablet. So and we translate the information from number of tablets and strength of the tablet to actual dose received and present it in EX. In EC, we are presenting the number of tablets in EX, but as per the protocol specification, so we had to report it in terms of number of mg. So we will be using this information on number of tablets and strength of the tablet and convert it into actual dose in terms of mg and present that information in EX, which is exposure domain. And if two tablets are taken, then EX dose will be 50 mg because two tablets multiplied by 25 mg each. So the total dose administered would have been 50 mg. If only one tablet is taken, then EX dose will be reported as 25 mg because one tablet only has 25 mg. So we will be applying this transformation for EX creation because the original collection was only in terms of tablets. So that goes into EC, and then the actual protocol specified units is mg. So we are making use of number of tablets and strength and then reporting that in EX dose variable. And then let's go to the example 2. So the protocol may specify that 100 mg of drug has to be administered and the dosage form is an infusion of 100 ml, which means if the total 100 ml is administered, the subject would receive 100 mg of the drug. So the collection here can only be made in terms of total volume of infusion administered. So here the drug has to be administered in the form of infusion. So we'll be only be able to collect the total volume of infusion administered first. So we report the volume administered in EC domain, and then we translate the information from volume of infusion administered and strength to actual dose received and present it in EX domain. Say for example, if 100 ml of infusion is administered, then EX dose received is 100 mg because 100 ml contains 100 mg, which is 1 mg per ml. So if the entire infusion is administered, then the subject would receive the 100 mg dose. So we are converting ml, the reported units of ml, to the protocol specified unit of mg here by using the concentration and the volume administered. And if only 35 ml is administered, EX dose will be only 35 mg because 100 mg in 100 ml is equivalent to 1 ml is equal to 1 mg. So if 35 ml is administered, we'll only present that information of 35 mg in EX dose variable. So we would present that 35 ml in EC, but 35 mg in EX domain. And then example 3. So in some studies where both planned dose and actual dose are collected, we use EC to present both doses. In EX, we only present the actual doses. So we have seen that in EC video that we have a variable called EC mode to capture whether the EC dose represented on that record is a scheduled dose or performed dose. And then In EX, we'll only be presenting the performed doses. EEC also allows us to indicate whether the scheduled dose is taken or not. So on the performed record, we would populate EC occur as N. So if it is not performed, but we'll only be presenting only those doses which are administered in EX domain. So we have seen three scenarios where there is a difference between EC and EX and what goes into EC and what goes into EX. So there can be a number of other scenarios just to give you a basic idea. So I have covered three examples here. And EX domain falls under interventions class of SDTM domains, and it has an expected record structure of one record per protocol specified study treatment and constant dosing interval. So what information is typically presented or collected for exposure is the name of the treatment, start date or time of the administration, and the date time of administration of the treatment, and then dose and dosing unit of the treatment, frequency of administration, for example, whether it is once daily or once in a week or twice daily or once in a month kind of information would be collected. And then route of administration, whether it is orally given, intravenously given, or intramuscularly given, and the dosage form, whether the drug is administered in the form of a tablet or capsule or injection, etc. And the location of administration, whether it is administered as in the hand or thigh, or whether if we have laterality also applicable. So we'll also collect whether it is left hand or right hand, wherever applicable. And then we also collect this information. Was the dose adjusted for any reason? If it is adjusted, the reason for adjustment. And then we also report the lot number of the treatment package. So now let us move to the lesson description and then see what we will be covering in this lesson. So in this lesson, we will see how to translate the volume of injection administered to protocol specified unit using drug concentration to create EX domain. So we are basically using a data set in which the volume of injection administered is collected, and we also have the drug concentration available to us in the raw data. So and we will be translating the volume into the volume into the total number of total drug that is administered to the patient. So and we'll be creating EX domain for that scenario. So let us now move to the specification. So here we have general notes. So variable name, label, and derivation is provided. So the general note says volume of injection administered is captured in IP admin dataset. The volume administered is captured in EC domain, and the amount of dose given in micrograms will be captured in EX domain. So study ID. So it says equals to the value from IP admin study variable. The base dataset for our EX domain, the raw dataset we are using is IP admin. So we are being asked to use the value from study to populate study ID. And for domain, so we are being asked to assign the value of EX. And we have useID variable. So it says derive by concatenating the values from IP admin study and IP admin PT. So which means we'll have to concatenate the values present in study and PT variables of IP admin dataset separated with a hyphen in between. And then we have EXE derivation. It says sort the records by useID, EXTRT, EXSTDTC, and then set to 1 on the first record of first record of the subject, and increment by 1 on the subsequent records within the subject. And then we have EXTRT. So it says derive by fetching information from a dataset called box. So from the variable content. So the base dataset is IP admin, but we are being asked to use the information present in a second dataset called box, but by linking IP admin to the box dataset and fetch the content variable. So derive by fetching content from box dataset by joining IP admin and box datasets based on IP box ID of IP admin dataset and kit ID of box dataset. So if the content is when there is a match between the kit ID and IP box ID, we would get the matching content variable value. If the content variable value on a particular record is PPO, then we are being asked to assign the value of placebo to EXTRT. Otherwise, if it is active, so then we are being asked to assign the text active to EXTRT. And then we have EX stores. So the derivation says derive by multiplying the value from IP QTY underscore raw, the quantity administered, and the drug concentration. So we have seen in EX that we have presented only the quantity in EC dose, but here we are trying to convert it into protocol specified units. So we have the concentration available and we have the total volume that is being administered. So when we multiply the quantity with the concentration, we will know how much amount of drug is actually administered to the patient. So, and we also have an additional note saying that assign as 0 when EXTRT is placebo. So there is a standard convention in exposure domains. So if the TRT value on a particular record is placebo, we'll have to present the dose as 0, indicating that 0 mg or 0 amount of active ingredient is administered. So that's why we are being asked to present 0 when EXTRT is equal to placebo. And then EX dosing unit, so we are presenting it in micrograms, and dosage form is injection, and dosage frequency is every week, and EX route is intravenous. So all these four variables information is pulled actually from the information present in the protocol. So these variables do not have information directly collected in the raw data, but as per the design we will know from the protocol that what is the dosing units and what is the dosage form and route of administration and also the frequency of administration. And then we have lot number. So it says derive by fetching lot number variable from lot dataset by joining IP admin and lot datasets based on IP box ID and kit ID of lot dataset. Assign the value of lot num to EC lot. So IP admin is the base dataset. We have the box ID present in IP admin dataset, and we have the lot number for each of those box IDs present in a dataset called lot. And the linking variable between these two is kit ID and IP box ID. We'll have to join these two and fetch the lot num variable and assign the value to EC lot variable. And then we have EXADJ, which is reason for dose adjustment. So it says equals to the value from IP admin IP ADJ variable after converting it to uppercase. And then epoch, so we are being asked to assign as treatment. And then we have EXSTDTC. It says derive the datetime value in ISO 8601 format by obtaining the information from IPSTDT underscore raw of IP admin dataset and IPSTTM underscore raw of IP admin. And then for EXENDTC, we are being asked to set the value from EXSTDTC. And then we have the specification given for study day variables EXSTDY and EXENDY. So we will check whether the administration date is on or after reference start date. Then we would get the difference between exposure start date and the reference start date and add 1 to that difference. Otherwise, if the date is before reference start date, we have to assign it as the difference between EXSTDTC and RFSTDTC. And then similarly, we have derivation for EXENDY. The only thing that changes here is instead of EXSTDTC, so we would have EXENDTC. So now this completes the specification for EX domain. Now let us move to the SAS program and the so here on the left hand side of my screen I have my SAS program that creates the EX domain, and on the right hand side I have my input datasets, intermediate datasets, and the final dataset that is getting created. So here I am creating some copies of the input datasets that will be used. So the main dataset is IP admin, and we need demographics for RFSTDTC to populate or to create our study day variables. And then we need box to fetch the ECTRT variable, EXTRT variable, and we need lot dataset to populate the lot number. So though I have used SV and SE here, so they are not used anywhere in the downstream programming. So IPadmin 01 is our base dataset. So let us take a quick look at our IPadmin 01 dataset and see what information do we have here. So we have study, patient number, folder, concentration of the drug, start date of administration, start time of administration, quantity administered, the unit of the quantity administered, and if if the dose is adjusted for any reason, why it is adjusted, and the box ID, so which means the from which IP box ID we have given this injection. So on each of these different visits, we might have used a different package. So we have the package number available here. So this will be used as linking variable to fetch the actual treatment content present in that box, or the lot number. So we had this box information. So we have the list of box IDs available and the content available in each of those box IDs, whether that box corresponds to active medication or whether a box corresponds to placebo medication. And then similarly, we have the lot number of manufacturing for each of the boxes. So we will be using IP box ID to fetch our treatment and also the lot number. So let us now move to the actual programming. So we are creating variables which are directly based on source variables. So we have seen in the specification, so most of the variables are either direct copies of SDTM raw dataset variables or derived simply by changing something on the input values. So are using our IPadmin01 as the base dataset and creating a new dataset called EX01. So we were asked to use the value from study variable to in study ID variable, so we are doing that. And for domain variable, we were asked to assign the text EX, and so we are assigning that here. And for usage ID, we were asked to concatenate the values present in study ID and patient with a hyphen in between. So we are achieving that using catx function here. And then we have IP con variable. So here IP concentration is present. So for EC dose variable, so we were asked to multiply concentration and quantity. So IP concentration is present as a character variable, and also IP quantity underscore raw is present as a character variable in the input data. So I am creating two temporary numeric variables to hold the numeric variance of concentration and also quantity. So converting IP conc using input function and base.in format and storing it in a variable called ipcon. So the raw original variable name was ipconc, and I have just created a numeric variant of it without the last c at here. And then IP quantity raw was the character format, and then I am converting it to uh, numeric using input function and base.in format and storing it in a variable called IP quantity, IPQTY. So if both IP concentration is not equal to null and IP quantity is equal to null, so we are populating our DEX dose as a product of IP concentration and IP quantity. So multiply IP concentration with IP quantity. So here, if we see here, 2 ml is being administered, which has a concentration of 50 microgram per ml, 500 microgram per ml. So what would be the value? So it would be 1000 microgram would have been administered. So here if we see, there is only 1 ml is administered, so which means only 500 micrograms of drug is being given to the patient. So we will have to present the actual total amount of drug received by the patient and EX dose variable. We will see in a while how this EX dose is appearing when we look at our EX01 dataset. And then when EX dose is not null, so we are assigning the EX dose unit as microgram in EX dose U variable. And then we are assigning the value of injection to dosage form, and then the frequency as every week, and the route of administration of as intravenous to EX route variable. And for EX ADJ variable, we were asked to convert the values present in IP ADJ to uppercase and assign it to EX ADJ. So we are making use of uppercase function to convert the values in IP ADJ to uppercase. And then we were asked to assign the text of treatment to epoch variable, so we are assigning it here. And then here we are creating our date in ISO 8601 notation. So we are handling it in two steps. The first one is to convert the date component which is present in IPSTDT underscore raw to ISO 8601 notation first, and then similarly we are converting the time value in IP SDTM underscore raw to ISO 8601 notation, and then finally concatenating those two. So here IPSTDTC is being created as converting the original value present here to numeric value because the format is 05/Jan/2010. So we call this as date 11 format. So we will be able to convert them into numeric when we use date 11 in format in input function. So we are converting these character date values to numeric first and then converting it back into ISO 8601 notation using YYMMDD10 dot format. So and then storing that date component in IP_STDTC variable. And then for IP_STTM, so here if we see, we uh, for the time to be in ISO 8601 notation, we need to have 2 character wide hours and 2 character wide minutes. But we do not have the leading zero here when the time is from 1 to 9. So here we need to add leading zero. How are we achieving that? So we have in format called in format called time5 to read the time values which are in this format, and we are converting those time values to numeric, and those converted numeric time values are again converted back to character using put function but with TOD6 dot format. So with TOD6 dot format, so whenever the hours is like from 1 to 9, so it would add that leading zero. So this 8 would be presented as 08 instead of just 835. So and then after converting the date component and time components into individual ISO 8601 notations, so we are concatenating both of them with a T in between as per ISO 8601 notation expectation. And then we are assigning EXSTDTC to EXENDTC as per the specification. Now let us go and check our EX01 dataset. So we had variables till IP box ID in our IP admin 01 dataset, and all the variables which are added newly are appearing towards the right of that variable. So we have study ID, usage ID, domain, IP concentration, IP quantity. So these are two numeric variants of the raw character versions of those variables. And then here we are creating our dose variable. So here we have seen that we have multiplied quantity and concentration to get the EX dose. So 500 multiplied by 2 is 1000. So and the dose is microgram. So 1000 microgram have been administered. So when this on this particular record, and then if we see here, so here it is 500 micrograms is administered. So here if we see only 1.9 ml of dose was administered, so it is getting translated to the total dose that is received as 950 micrograms. And then we have other variables that were assigned, and then we created our EXSTDTC and EXENDTC. So we created it EXSTDTC by first individually converting the date to ISO 8601 notation in IP_STDTC, and then IP_STTM underscore raw to ISO 8601 notation in IP_STTM. So here if we see, the leading zero is added to the time values, which was not present in our original raw variable. So and then we concatenated these two with a with a T in between. So here we have the T, letter T. And now let us move on to the next derivation. So we are now trying to create our EXTRT variable. So the specification mentioned that we were supposed to use the information present in box content to populate our TRT. So in order to join IP admin and box dataset, I am using a procSQL left join. So I am using IP admin on the left hand side, which is as the first dataset, and I am specifying it with an alias of A, and on the right hand side I'm specifying box 01 and I'm using an alias of B for that, and I'm linking these two datasets based on the values present in IP box ID of EX01 and kit ID of box 01, and then fetching the matching content. So and after fetching the B dot content is nothing but we are supposed to translate that to a different value for EXTRT. So if B dot content is PBO, so we were asked to populate it as placebo. So we are assigning the text placebo for EXTRT when it is PBO. Otherwise, when it is active, so we were asked to assign the text of active to EXTRT. So we are handling that using case when logic or within procSQL. And then in the next step, we are trying to, let's take a look at EX02 and then see if we have our EXTRT populated. So we have EXTRT populated. So based on the matching kit ID or the IP box ID. And now we'll now move on to EX03 step, so which is actually fetching our EX lot variable. So as per the specification, we were supposed to join our IP admin, so which is now we have used IP admin to create EX02. So EX02 is being joined with our lot dataset based on the values present in box ID of IP admin and kit ID of lot dataset. So when on the matching record, the lot number had to be fetched as EX lot. So we are doing that here. So let's take a look at EX03 and to see if we have the lot number pulled in. So we have the lot number pulled in for the associated kit ID on each record. And in the next step, we are trying to create our study day variables. So in order to create the study day variables, we need our reference start date to be pulled into our exposure dataset. So we are doing that using our merge statement. So we are joining our demographics dataset to exposure dataset, and when in the merge, so we are only bringing the variables UseUpJD and RFSTDTC from DM01 dataset, and then the merge is at subject level. And in order to calculate the study day variable, we need to have the date values available in numeric format. So we are creating numeric date versions for our reference start date, exposure start date, and exposure end date, and storing them in RFSTDT, EXSTDT, and EXENDT. And then we are creating our study day variables here. So here in the first instance, so we are checking if both EXSTDT and RFSTDT has a value populated using NMES function, and then creating our study day using this formula. And then for EXENDY also we are checking EXENDT is not null and RFSTDT is not null using NMIS function again, and deriving study day using this formula. And then there was a requirement that so if EXTRT was placebo, we were asked to set the value of EX dose to 0. So we are doing that here. So let us now take a look at our EX04 to see if our study day variables are populated. So we have our EXSTDY populated and EXENDY also populated. So let us also cross check if our dose is becoming 0 on the records where EXTRT is placebo. So here we have a placebo row. So on that record we have the dose as 0, so which is handled here on this line of statement. And then finally we are creating our EXSEEK variable. So we were asked to sort the records based on UseUpJD, EXTRT, and EXSTDTC. And on the first record of each subject, we were asked to use the value of 1 for EXSEEK. Otherwise, we were asked to increment by 1 on the subsequent record. So we are handling that using this logic. And then finally, I am assigning the list of variables that have to be kept to in the final dataset to a macro variable named varList, and I am assigning the required labels to all the variables, and then keeping only the variables which are to be kept in our final dataset. So let us now take a look at our final dataset, which is EX06. So this now has completed our SDTM EX program, and we have only the variables that are required in the final dataset: study ID, domain, UseUpJD, sequence, TRT, dose, dose unit, dosage form, dosage frequency, route, lot, reason for adjustment, epoch, start date, end date, study day of start, and study day of end. So these are the variables that were supposed to be kept as per the specification. So we kept all of them in the final dataset. So this is how you can create your SDTM EX domain. Thank you for watching and keep learning.